Welcome to our in-depth tutorial where we explore the power of NVIDIA's NIM API for testing and comparing various large language models, LLMs, using Python and Streamlit. In this video, we'll walk you through the process of setting up a dynamic comparison tool that allows you to select multiple LLM models and generate responses from each of them in real time. Our primary focus will be on comparing three cutting-edge models: Meta's LLaMA 3.1 405B, NVIDIA's Nemotron 4 340B, and Google's Gemma 2 2B. We'll dive into how each model performs across different tasks, helping you determine which one offers the best results for your needs. By the end of this video, you'll have a comprehensive understanding of how to implement this comparison framework, and you'll be equipped with the knowledge to make informed decisions about which LLM model suits your specific applications. Let's get started. Let's diving into the code behind our Streamlit app that leverages the NVIDIA NIM API to compare responses from multiple large language models, or LLMs. Let's walk through each part of the code so you can understand how it all works together. First, we start by importing the necessary libraries. We're using OS for accessing environment variables, Streamlit to build our web app, OpenAI for the API interactions, and dotenv to load our API keys securely from a.env file. Next, we load our environment variables, specifically our API key, using the load_dotenv function. This ensures that sensitive information like the API key is kept safe and not hard-coded directly into our script. Moving on, we set up the title of our Streamlit app with sttitle, which displays NVIDIA NIM platform at the top of our web app. Then, we use sttext_area to create an input field where users can enter their prompt. By default, we've set an example prompt that asks about GPU computing in 50 words. Next, we define a list of available models, ranging from Meta's LLaMA 3.1 to NVIDIA's Nemotron 4 and Google's Gemma 2. Each model is represented by its identifier, which will be used to interact with the API. In addition to the model identifiers, we also provide detailed descriptions for each model. This information can be useful for understanding the capabilities and use cases of each LLM. We store these descriptions in the model details list. Now, we create a multi-select dropdown where users can choose the models they want to compare. The stMultiSelect function allows multiple selections from the list of available models. Next, we initialize the OpenAI client using the OpenAI class. Here, we pass the base URL for the NVIDIA NIM platform and the API key loaded from our environment variables. This client will handle our interactions with the models. Now, let's get to the core functionality. When the Generate Responses button is clicked, we loop through the selected models and send the user prompt to each one. We set parameters like temperature, top_p, and max_tokens to control the behavior of the text generation. The responses are streamed back from the API and displayed in the app. As the responses come in, we capture the output in chunks and display them under the corresponding model name. This allows users to compare the output side by side. We also included the option to display detailed information about each selected model. This is useful for users who want to dive deeper into what makes each model unique. And that's the complete walkthrough of our Streamlit app code. This setup gives you a powerful tool to compare different LLMs using NVIDIA's NIM API. Whether you're experimenting with prompts or evaluating models, this app can help you make informed decisions. Now run the app and try with different example. We'll try now what is machine learning in 50 words. We'll wait while response will come. Now you can see the response and do your comparison which one is best for your needs. If you found this walkthrough helpful, please give this video a thumbs up and subscribe for more deep dives into AI encoding. Drop any questions or thoughts in the comments below. I'd love to hear from you. See you in the next video.